Welcome to Digital Goldmine, your go-to channel for everything space exploration. We're here to fuel the curiosity of space lovers worldwide, covering black holes, distant galaxies, and everything in between. We bring the cosmos to you, exploring the unexplored and appreciating the unseen. Join us, hit subscribe, and like this video. Today we delve into a captivating topic. What would if a giant asteroid were to hit Earth? Imagine a colossal asteroid hurtling towards Earth at breakneck speed. It's a chilling thought, isn't it? But how likely is it really? Well, asteroid encounters are more common than you might think. They're happening all the time, but most asteroids are so small they burn up in our atmosphere before reaching the ground. However, there's always a slim chance that a larger, more destructive asteroid could make its way to our planet. To pose a real threat, an asteroid would need to be at least 1 kilometer in diameter. That's roughly 3 times the length of Central Park in New York. An asteroid of this size could cause widespread destruction and significantly alter our way of life. So, while the likelihood of a catastrophic asteroid strike is low, it is not impossible. That's why scientists around the globe monitor space diligently, keeping their eyes peeled for any potential threats. Now, what are the potential scenarios if such an event were to occur? Upon impact, the asteroid would release energy equivalent to millions of nuclear bombs. Imagine this. A celestial intruder, an asteroid slamming into our home planet with unimaginable force. This colossal impact would create a massive crater, the size of which would depend on the asteroid's size, speed, and composition. The immediate aftermath of such an event is nothing short of catastrophic. Picture the instant of collision, when the asteroid's kinetic energy is converted into a shock wave that radiates outward from the impact site. This intense release of energy would vaporize the asteroid and a significant portion of the Earth's crust, creating a blistering fireball that would incinerate everything within its reach. But the destruction doesn't end there. The impact would eject an enormous amount of debris into the atmosphere, creating a blanket of dust and ash that would darken the skies around the globe. This cloud of particulates would block out the sun's rays, leading to what scientists refer to as an impact winter. The force of the asteroid's collision would also trigger seismic activity far beyond the impact site. The ground would shudder and quake, and the shockwaves could potentially set off volcanic eruptions and tsunamis, adding to the initial devastation. In the immediate aftermath, the world as we know it would be unrecognizable. The landscape around the impact site would be utterly transformed. Vast forests would be flattened, cities would be reduced to rubble, and the air would be filled with the dust of destruction. This cataclysmic event would not only reshape the physical world, but would also have profound effects on the Earth's climate and ecosystems. The dust and ash in the atmosphere would alter weather patterns, causing temperatures to plummet and disrupting the delicate balance of life on Earth. But the immediate impact is just the beginning. Let's explore the long-term effects. The aftermath of an asteroid strike is a grim reminder of our vulnerability in the vast universe. But it also highlights the importance of monitoring near-Earth objects and developing strategies to protect our planet from potential threats. The long-term effects of an asteroid strike could be even more devastating than the initial impact. Imagine a world plunged into darkness, a scenario referred to as a nuclear winter. This isn't just a scene from a science fiction movie, but a very real possibility if a large asteroid were to collide with our planet. When an asteroid hits, it throws up an enormous amount of debris into the atmosphere. This cloud of dust and particles can block out sunlight for months, even years, essentially turning day into night. The lack of sunlight doesn't just mean we'd be fumbling around in the dark. It would have severe implications for life on Earth, disrupting photosynthesis, the process plants use to convert sunlight into energy. With plants unable to grow, the entire food chain would be disrupted, leading to widespread famine among animals and humans alike. In addition to a nuclear winter, an asteroid impact could also cause significant disruptions to the global climate. The collision could trigger massive wildfires, releasing vast amounts of carbon dioxide into the atmosphere. This could lead to an enhanced greenhouse effect, further disrupting our climate and leading to extreme weather events. But perhaps the most frightening long-term effect of an asteroid strike is the possibility of mass extinctions. History has shown us that large asteroid impacts can wipe out a significant portion of life on Earth. The most famous example is the asteroid that struck our planet 65 million years ago, leading to the extinction of the dinosaurs. If a similar event were to happen today, the human race could very well be on the list of species that don't survive. So, with the potential for such catastrophic effects, What measures are in place to protect us? Fortunately, scientists and space agencies around the world are working on ways to defend against asteroids. These celestial threats may seem like an insurmountable challenge, but human ingenuity is nothing if not resourceful. Our primary defense strategy? Detection and deflection. Firstly, let's talk about detection. Various space agencies and observatories around the globe are constantly scanning the skies for near-Earth objects, or NEOs, that could pose a threat. These include asteroids and comets that come within about 30 million miles of our planet. The goal is to identify potential threats years, decades, or even centuries before they could hit Earth. This gives us ample time to prepare and potentially deflect the asteroid. Speaking of deflection, there are several proposed methods to throw these space rocks off their collision course. One of these methods is the kinetic impactor technique. Just like a game of cosmic billiards, a spacecraft is sent to collide with the asteroid, altering its trajectory just enough to spare Earth. It's a simple hit and run, but on a galactic scale. Another proposed method involves the use of gravity. The gravity tractor technique, as it's known, involves positioning a spacecraft near an asteroid. The mutual gravitational attraction between the two bodies would slowly, over time, nudge the asteroid off its Earth-bound path. Yet another proposal is to use nuclear explosives. While this may sound like something out of a sci-fi movie, it's a serious consideration. The idea is not to obliterate the asteroid, but to detonate the explosive near it, vaporizing part of the asteroid and creating a thrust that changes its course. While the threat of an asteroid strike is real, rest assured that we are not entirely defenseless. As we continue to advance our technology and understanding of the cosmos, our ability to defend our planet from these celestial threats will only improve. So let's keep our eyes on the skies and continue to explore and protect our place in the vast universe.